Second PUC, second chapter, inverse trigonometric function. Already in the last video, we discussed the formulas in all the formulae in trigonometric functions, and also we recall all the definitions of types of the functions. That is one injective function, onto surjective function, bijective function, then inverse of the function. These are all we discussed in last class. So see again I am recalling once. You see what is the definition of inverse of the function? When it is inverse of the function is existing. See, a function is bijective. A function f is bijective, then the inverse of the function is existing. The inverse of the function is denoted by f inverse. See, f is mapping from a function f is mapping from a to b is bijective. Then f inverse, the inverse of the function f inverse is mapping from b to a is exist. That means if f is the bijective, that means 1 and onto, then only the inverse, then it is called bijective function. Then only the inverse of the function is exist. So coming to the trigonometric functions also in particular interval, in particular domains, these functions also bijective functions. These functions also bijective functions. So inverse of these functions, that means inverse of the trigonometric functions also existing. So these inverse of trigonometric functions we are writing as the sine inverse and cos inverse and tan inverse and cosecant inverse, secant inverse, cot inverse. These are called inverse trigonometric functions. Inverse trigonometric functions. You see now sin x, for example, sine function is there. Sine function is a bijective function. What I told you is a bijective function. So that the inverse of the function is existing. So it is bijective in all the intervals. Completely it is bijective on a real or some particular interval. You see. So this is bijective in some particular interval only. Because you see, for example, sine 30 degrees, you see, sine 30 degrees value 1/2. If I write sine 150 degrees, sine 150 degrees, sine 150 is equals to how we are writing sine 180 minus 30, that is equals to sine 30. Sine 30 value is equals to 1/2. That means 30 degrees image is 1/2. Next to 150 degrees image also 1/2. That means it is not a bijective, it is not an injective function. No, it is not a one-one function. What is the definition of one-one function? Every element in A having different pre-image, different image in B. Every element have a unique image in B. Then only it is a bijective function. Then only it is a injective function. That means one function. But you see 30 degrees having same image, 150 degrees also having same image. So it is a bijective function. First of all is the one function. It is not a one function. One injective, both are same. It is not a one function. So it is not a bijective function. What is the definition of bijective function? A function is injective and bijective. Injective and surjective. Injective and subjective are one or onto. Then only it is bijective. First of all, this is not a one function, so it is not a bijective function. So these trigonometric functions in particular intervals only. In particular intervals only, these are bijective functions. So you see what are the intervals? You see the intervals. We are discussing about only sine now. So minus pi/2 to pi/2. In this interval, sine function having unique images. You check it. You take any angle. that result is not repeating, you see. For example, sin 30, sin 40, sin 45, next to sin 60, sin 70, sin 80. You check in the trigonometric functions table. 0 to 90 and 0 to minus 90 to 0. So these numbers are not equal for any angle about the sine. So this is the sine function is bijective in this interval. And similarly, pi by 2 to 3 pi by 2. These are all closed interval. Next to 3 pi by 2 to 5 pi by 2 dash dash. Coming to left side, minus 3 pi by 2, minus 270 to minus 90. Next to minus 5 pi by 2 to minus 3 pi by 2. Next to dash dash. In these intervals also, these in these all the intervals, these trigonometric sine function is bijective function. So that means what we concluded is the trigonometric functions are bijective, but for some particular intervals only, not all the real values. So in particular real values, that means the subset of the sub-intervals of real. So in these intervals only, these functions are bijective function. Next, so these minus pi by 2 to pi by 2, this interval is called principal value branch. Principal value branch. This is the definition of principal value branch. So what is the definition of the principal value branch? Minus pi by 2 to pi by 2 interval is called principal value branch of which function? Sine inverse function. So this is the definition of sine inverse function. You see, next f of x is equals to y. F of x is equal to f is a bijective function defined by f of x is equals to y. Then x is equals to what we are writing? F inverse of y. X is equals to what? F inverse of y. Similarly, sin pi by 3 is equals to, that means sin 60 is equals to what? Root 3 by 2. Now pi by 3 is equals to what we are writing? Sin inverse of root 3 by 2. Sin inverse of root 3 by 2. So like sin inverse of 1 by root 2 pi by 4. Sin inverse of 1 pi by 2. Sin inverse of 1 pi by 2. Sin inverse of 1 by root 2 pi by 4. So like ulta, you recall once all the trigonometric values. Okay. And one more thing you remember. So this one you remember. F of f circle f inverse of y is equals to y we are getting. F inverse circle f of x is equals to x. That means you see one example for this. Example, sine inverse of 1 by 2 is equals to 1 by 2 only. 1 by 2 only. Next, sine inverse of sine pi by 3 is equals to pi by 3 only. Pi by 3 only. So this value directly we are writing here. F circle f inverse of y is equals to y only. F inverse circle f of x is equals to x only. Now coming to here for the sine of sine inverse of 1 by 2 is equals to 1 by 2. Sine inverse of sine pi by 3 is equals to pi by 3. Okay. So similarly, remaining trigonometric functions also having some different domain, different codomain, and different principal value branch. So here we need to remember the range, domain and range. That range nothing but principal value branch. So this table you remember once. So in this chapter, what you need to remember now up to now, that is the concept only. From these you remember this one. So sine inverse of function domain is minus 1 comma 1 and range then nothing but principal value branch, that is equals to minus pi by 2 to pi by 2. So similarly cos inverse close to minus 1 comma 1. Range is close to 0 comma 5. Next cosecant inverse domain is r minus of over to minus 1 comma 1. Next range is close to minus 5 by 2 comma 5 by 2 minus set of 0. So for your seniors this year they are discussion only. What is the range of cosecant inverse? What is the range of cosecant inverse? One more question. This one only can given. What is the answer? Cosecant of minus 5 by 2 comma 5 by 2 minus set of 0 is the answer. So from this table only every year they are asking one more question. This table you remember once. Okay. Next you see note for negative values what will give the inverse trigonometric functions you see now. So first one, sine inverse of minus x is equal to minus sine inverse of x. Sine inverse of minus x is equal to minus sine inverse of x. Second one, cosecant inverse of minus x is equal to minus cosecant inverse of x. Next, third one, tan inverse of minus x is equal to minus tan inverse of x. Fourth one, cos inverse of minus x is equal to pi minus cos inverse of x. Fifth one, secant inverse of minus x is equal to pi minus secant inverse of x. Sixth one, cot inverse of minus x is equal to pi minus cot inverse of x. So these are the negative values of inverse trigonometric functions. Remember this one. Why not written in order you see? Just you remember sine inverse, cosecant inverse, tan inverse of minus function will give minus of same functions only. So next to cos inverse, secant inverse, cot inverse is pi minus of the functions. Example you see sine inverse of minus 1 by 2 we need to find. How we are finding? This is equals it is in the form of sine inverse of minus x. So this is equals to minus sine inverse of 1 by 2. And this is equals to minus sine inverse of 1 by 2 is equals to what I am writing? Sine 30 degrees, sine pi by 6. So it is in the form of sine inverse of sine x. That is equals to what? X only. So this is pi by 6. Minus pi by 6 is the answer. So like that we are writing. So similar to remaining you write. Next cos inverse of minus 1 by 2 only I am solving this one. You see cos inverse of minus 1 by 2 is equals to pi minus cos inverse of 1 by 2. That is equals to pi minus cos inverse of cos pi by 3. Cos pi by 3 value 1 by 2. So pi minus cos inverse of cos x is equal to x only. So pi by 3. So pi minus pi by 3 equal to 3 pi minus pi by 3. That is 2 pi by 3 is the answer. So like this we are solving. Okay. So this is the negative values of inverse trigonometric functions. Okay. Next principal value of trigonometric function. Principal value of inverse trigonometric function. Inverse trigonometric functions. Principal values of inverse trigonometric function. See, so the value which value lies the principal branch value. What we call that one? The principal value branch. Which value lies the principal value branch? That value is called the principal value of inverse trigonometric function. So you see here. So here, why we change like this? Because the result we are writing in principal value branch. So what is the principal value branch of cos inverse? Cos inverse principal value branch what? Closed interval of 0, pi. So the result also we are writing in closed interval of 0, pi only. That result is called principal value of inverse trigonometric function. So how they are asking this question? Find the principal value of cos inverse of minus 1 by 2. So how we are solving? So this is equal to like this we are solving. These 2 pi by 3. This 2 pi by 3 is belongs to 0, pi. 2 pi by 3 120 lies between 0 to 180. So these 2 pi by 3 value is called principal value of cos inverse here. Cos inverse. So what is the definition of principal value? Which value of the inverse trigonometric function lies the principal value branch. That value is called principal value of inverse trigonometric function. Okay, this is the introduction of inverse trigonometric function. So what you need to remember? So that the table you read perfectly. From the table you are asking one mark question, and without using these we can't solve the problems. So you remember these are the formulas. Then we are solving the exercise. Okay. In next video we are solving first exercise. Okay.